Right, let's solve the first one quickly and see what we can get. Right, the first question they're saying, given that f of x equals to cos 2x, now that is the graph of cos, and then there is a g of x equals to this one. We did something like that yesterday again. Now the first one they say solve for x if f of x equals to g of x on the interval of negative 90 degrees to 180 degrees again. So what are some of we must equate the two graphs again. So if you equate them, what do you have? We'll have cos of 2x equals to sine into x plus 60 degrees again. Then if you have this one, you check the angles are not the same again. So if angles are not the same, it means we're going to use which rule? Then we use cofunctions again. Then we know this that we change to cos or to sine again. So my change here to a sine again. If you like, you can change to a cos, still fine. So now, but you can keep one method to make sure that you change one. So now let's change to cos again. So it means this side will be cos of 2x equals to the cos into 90 degrees minus, what is the angle? X plus 60 degrees again. Then now we must close this bracket again. Then now we can simplify this bracket. Cos of 2x equals to the cos of, now what do you get if you simplify the bracket? So it will be 90 degrees minus 60 degrees minus x again. Now so that we can work out the like terms, cos of 2x equals to the cos into, now what do you get here? 30 degrees minus x. What I get? From there, you know we can make your, what is your reference angle? Yeah? Which side? On the right hand side. So what is the angle on the right hand side? 30 degrees minus x. That is your reference angle again. Right now. And then now, it means our sign must be positive because looking on the left hand side and the right hand side, the one that is positive there again. So now if they are positive in that case, it means what we must do? We must show that they are positive in which quadrant? First quadrant and the third quadrant. Yeah, not that. Right, then from there, what do you do? We're going to have in first quadrant, then we're going to have our reference angle, meaning this side, 2x equals to the reference angle, which is the first quadrant of 30 degrees minus x again, plus k dot 360 degrees, where k is an element of integers again. Now, 2x equals to, we should take x to the other side again. So now, it means 2x plus x again equals to 30 degrees plus k dot 360 degrees. Now what do we have this side? We'll have 3x equals to 30 degrees plus k dot 360 degrees again. Then now what do we have? We have to divide throughout by 3 again. So x equals to, what is 30 divided by 3? You get 10 degrees plus k dot 360 divided by 3, 120 degrees. Now that will be the first part of the general solution. Now let's get to the second quadrant, because that is where we used cos. So it means should be which quadrant where cos is positive? Quadrant number 4 again. Now in quadrant number 4, then we say, okay, now on the left hand side we get 2x again equals to, then we have quadrant number 4. Then we have to say 360 degrees minus, what is our reference angle? 30 degrees minus plus k dot 360 degrees, where k is an element of integers again. Now let's work out this thing. So 2x equals to 360 degrees. Then when you multiply throughout by negative, you're buying plus x plus k multiplied by 360 degrees again. I mean x equal to by negative. Then after we to subtract again. So shall I x equals to, now 360 minus 8, what do you get? 380 degrees again plus k dot 360 degrees. I mean that is our two general solutions. But what was the question? Solve for x. So for which interval? We must maintain this interval again. So we'll check our values by substituting the integers again. So now let's put k equals to 1, or let's say k equals to 0. Let's write our interval here so that we can write. So we said where x is an element of negative 90 degrees to, is it 180? Like this. Now let's put k equals to 0 for this side. What do we get? So it means we'll have x equals to, now if k is 0 here, what do you get? 10 degrees. You will get interval. Yeah? You will get interval minus 90 to 180. Yeah? Then there will be 10 degrees again. Now let's put 1 here. If you put 1, what do you get? If k equals to 1, what do you get? Yeah? 130. You will get interval ever filling you now. 130 is within 180 again. So we'll say 130 degrees. Now let's put minus 1. So if you put minus 1, what do you get? Negative. You will get interval. Yeah, well, is this interval. So negative 110 is somewhere outside the 90, negative 90 again. So we don't take that. So now let's check. If we put 2 here, what do you get? You get 230 is outside the interval again. So now if you put negative 2, 220, then it's outside. Now let's come to this side. Now let's put k here to be 0. What do you get? Yeah? You get 38. It's outside the interval. If it's 180 again. Now if you put 1, obviously it will be more big greater. Let's put minus 1. You're buying negative 30 degrees is within the interval. I feel it before negative 90 degrees again. Now, if you put minus 2, what do you get? Negative 2. Negative. So running, our solutions are done again. So the values of x is equals to 10 degrees, 100 or 130 degrees or negative 30 degrees. I get. So that would be the first solution of that part. So there are 3 intersections. Yes. Yeah. Where? Right. That was the case. Now the second one that says yes. Yes, agree. If one if it or the pick over here. So if negative 1 ya theta or negative 2. So you stop there because they will be continue growing outside the interval again. So if they are literally you put them up until you get all the solutions. If they get outside the interval, then you stop again. Yeah. Right, the second one they say sketch the graph of this one. Now, sketching is not something that is difficult. Of course, we're going to calculate again. But if you understand the shifting of the graph, you can draw the graph easily again. Now, on this interval, drawing the original graph, then you can apply your shifting of the graph again, or your changes or transformation of the graph. Now, let's look at this graph. If for what field cos 2x, so what is the difference of this graph and this graph? What do you mean? Between cos x and cos 2x. What do you mean? Yeah? What do you mean? You affect the scale again. Now from the scale running, it shows that there will be more frequencies or there will be more waves inside the period of 180 degrees again. So now you are okay with the original graph. Then you are going to squeeze it again. Then we have more values. Then now you can draw original graph and apply the shift or the transformation. Now what happened here on the side, on the original graph of sine x? Uri shift 60 degrees to where? To the left. So if you draw original graph of sine x and you shift it 60 degrees to the left, then get your graph. Is it hard to draw original graph? Because the original graph is not changing again. Now let's draw they set on the same set of axes. Now from negative 90 to that other part. Now let's see if we can do them nicely. Let's do our Cartesian plane. So of course we can put 1 and 2. This side minus 1 minus 2 again. Now we can put our 90 degrees and 180 degrees. What level 180 again? This side what level negative 90 degrees. One again. Now I know that the graph of sine will start from what? From 0 again. Then from 0 again. Then we'll come to at 90 by again. 1 again. If you to make sine, then from 1 again 0. Then from there I to a modima 0 to the negative side here again. Negative 1 there will be a turning point here. 1 again. So now if I have to draw the original graph will be something like this. Can I graph again? The graph of sin x again. Namile, una graph ya sin x one pile mo. Labar lady wa. Shift 6 units to the left. Okay. Now, our shift 60 units to the left. The important part is to shift the turning points again. The turning points now. If I shift this point here at 90, you shift to the left by 60. Ora you subtract 60 here. Oh, guy. 30. Ora this turning point you about my 30 degrees. So one again. Ora this turning point is I guess about. You buying it? The turning point will be here. Well, 30. Let's put a dot here. One again. That will be the turning point. Now, graph yaga we kacha at 180 at 0. Now, so you kacha at what point now? Rora subtract 60 mo again. Rawela marauka 60. We must go back there by 60 units. So, guys, 1. So we can put 120 here, but you must estimate well again. 120 degrees here. So that my graph is going to cut here. When again, then from 0, it must shift 60 degrees to the left again. From 0, so you can move at that point again. So what are you guys? Negative 60 degrees. So when again, I mean this turning point. But now, knowing that here it will be my turning point. And from this turning point, at 60. From here, you must cut at what? 120. That's a cut 180 again. And then from there, you must continue going that way. Then it will cut one again. Then from here, it must also continue going that way. So it will cut at that point. So that the green part will be my graph after that. One again. Writing the coordinates here to be what? 30 degrees and 1. Now this one will be negative 60 degrees and 0. This one is no longer 180 shifted by 60 units. One again. So it will be 120 degrees and 0. One again. Now ameliorating. When you're done like that, what do? You can erase the red graph. Now the green graph is what we want. Is that clear? But of course, you can use your calculator to do that. Now I find it much simpler using the original graph because I understand the shifting again. Now, what's left? Let's see. The other part will be cos of 2x again. Let's draw graph of cos x and see. I know that the graph of cos x, you're buying it. At 1 is making a turning point again. From there, you cut at 90 again. From there, it will come to make a turning point at 180 again, which is negative 1 and negative 1. Then from there, you cut at 0 here. One again. So the original graph of cos will be something like this. And then now it will be something like this. That is the original graph of cos for this interval again. Then now, after that, what should I do? They increased what? The frequencies again. So changing the interval. So knowing that, okay, even if I change the interval, or at 1, the turning point will still be here. So one again. Now let's find the turning point will still be at this point again. But now, monosanji 10 udima 90 here. I said go 10 one again. I said go catch up. Where? Halfway from that. Why? Because they said cos of 2x. So running Mulabe Kata 90, I divide 90 by 2. One again. With a scale of that, 45. So 45 must be somewhere here. So right at this point, then my graph is going to cut at this level. One again. Then now, Mula from there, we are 180. 180 weight, and now I say 180. 90. One again. Because half of 180 is 90 again. Then at 90 here, it will be a turning point. One again. And then now my graph will continue at 45 here. Again. Now remember the graph is just making the waves. Running from if you add 45 from 90, what do you get? Across scale. For our scale is how much? 45 degrees again because of these two theta. Then now, right at 100, you said, okay, 135, 825 here. What should we have? The graph must cut at this point again, and then it must continue to go that side if like a 90. So now, this side running at 45, which is the center, negative 45. The graph must cut this point again. And then now at 90, the graph must come and turn here. So now let's join the graph and see what we can have. It means from the turning point coming to this one, another turning point coming to this one, and then you must go like that. In fact, from here, right at 180, it was supposed to make another turning point to be like this. And then now, from there, at 45, and then at 90, now the red graph is what we are looking for. And then we can take away this one. Then now we can write your points on the red graph, saying now 90 degrees and minus 1, and then this one will be minus 90 degrees and minus 1, and then of course we can write the coordinates here, 180 degrees and 1, so on. So now these are the two graphs that they are looking for. And then how many intersections in this interval? How many intersections do you see there? How many? 3. Hence, recommend how many solutions? Recommend how many solutions? 1, 2, 3. So I said these solutions, they are saying the intersection of the graphs again. So within that interval, they're going to intersect that guy. So if you draw the graph, they intersect 3 times and you find 2 solutions. It means same short or 1. So you must be careful on that. Any question? Is there any question so far? So that is how to draw the graph, but you can use your calculator. Make sure that you draw the correct graphs again. If you let the method of calculator, use it correctly. Now let's see the next question. Write down the period of G of, now look at what is G? It's sine. Again. Now on this sine, level now they're saying the value of x must be multiplied by 3 over 2. Again. So let's write it. We're going to have G of now 3 over 2x. What should be the answer here? Sine into more x agar mo so x value G of x. What about substitute the G of x? By substitute 3 over 2x. Or more x substitute. So right over guys 3 over 2x because come moving x right change by 3 over 2x again. Then plus 60 degrees. Now they are looking for the period. Now I said for you to get the period, you must take out the common factor here again and see what you get. Now what is the common factor? We rapidly down 3 over 2 again of sine into what? X. Now you divide this 60 by 3 over 2. What do you get? Simply say 60 degrees divided by, but you use Shumisha divide here over like this again. 60 divided by, then write say 60 degrees divided by 3 over 2. Then you get the correct answer. What do you get? You get, so that is plus 40 degrees. Now, what will be the period now? Of course, what is the period, original period of sine? Okay. What is the period, original period of sine? Sine graph. Okay. 360 degrees. Now, we will divide again. We will divide again. What is the coefficient of that angle then? So this value is supposed to be 3 over 2 here, not outside. Because that should be an angle. So the coefficient is 3 over 2. But this can be written as 360 degrees divided by 3 over 2. What is the answer? Yeah? 140. Right now, you're going to write that the period is 240 degrees. When again, that is the period of that graph if is affected in that case. Any question? You understand how to take out the common factor. Then I'm saying the common factor that you take is part of angle, I guess. You should write it here. Now I said the period of the graph will always divide by the coefficient of the angle, I guess. Now the angle here is kind of is x plus 40 degrees. So when I get, now if the coefficient of this angle is 3/2. Now for the period of the graph that you want to get, then it must say original period, which is 360 degrees, divided by the coefficient of the angle. So that's why we divided by 3/2. And that will be the period of this graph. Determine h. If h of x is what? F. What is f? Can you see f? It's a graph of sine, cos. Now let's apply this and see what we get. Because they want what? Determine h of x. They want the new graph, again. Now, let me erase this once. What are the varying mode? Let's try to copy this. For now, let's just say we have this part. Can you see this part? F again. So it means h of x equals to graph f. Graph f are more f inside the bracket of leg. F of bracket of leg x. So orang kali dia cuma orang yang mesti letak x again. So now level lagi juga bilang istilah mula sunjuk x bilang. So korkara graph f. Will kan alih graph f cos 2 but cos of 2 mula sunjuk x orang baca cinci tu mana kan orang x kan alih x minus 45 degrees. So what again? Then now this one negative one apa as a summation x. So we're going to say minus 1. Now can you see now the h of x? So h of x equals to, they just said what they want h of x if that is the case. So we can leave it here, avoiding to multiply things. So when again, as well as you will write it on. This is your h of x. Then you are done in that graph. Any questions? So you must be careful or move change ladula x or no so you change on the function again. Now let's see what we can have on the next part. Now here we don't have to draw, we can write here. Now the graph of h of x is equals to a the tan of x for the interval of negative 180 degrees to positive 180 degrees. Here this graph is drawn where x is not 90 degrees. So it means the graph at negative 90 degrees is not existing. That is why we have the asymptote again. Then it's sketched below. Now determine the value of a. Can I get the value of a quickly? I said determine the value of a. What is the value of a? How did you get that? How did you get that value? Okay, A imaging. A imaging. Normally image the amplitude. But okay, yeah, image the amplitude. What is the amplitude of this graph? What are you going to change the direction again? It's now demand. It's now demand. Kamu mau change direction ni yaudi. Yeah? Yaudi. Apa ya 90 kini decrease surah yang tabe ya left or right. Kamu the point here the graph is changing direction. Can you see that? The point here is changing direction. So running the value of a give guy. Agar amplitude mau change direction. So right change direction h2. Agar if you gabele sign. What will happen here? The graph will turn, that will be the turning point again. So now, even look at turn around in motion change direction, then that will be what? The value of A, which is what? 2. When again, think about cos or sine. So at this point, sine idea this or this again. Look cos idea this 10 or this 10. When again. So that's why I will say the value of A there will be 2. Because A on the other side, the affect the height. How high will the graph go again? 10 or change the direction, which is now we just say the amplitude. So can you see also drawing in party of imaging again? Now 8.2. If f of x equals to cos of x plus 45 degrees, sketch the graph of this on the diagram provided on the answer sheet. So you can sketch on the same interval again. Marabanya graph cos of x plus uri linga graph ya cos of the original. Shift guy to the left by how many? 45 degrees. So when I get, you can say 45 degrees, but with 45 degrees. Now, normally, let's draw the normal graph and see. The normal graph, I know here must make a turning point again. And then here, Sanji, the cut again. And then at minus 1, you must make a turning point. From this part, original graph must be like this again. And it means this side, it must also be not this one. Cannot be correct. From there, remember the original graph scale is 90 again. From there, Sanji, if it will 90 degrees. From here, Sanji, if it will 90 degrees. From there, we have this one. And then from there, it will go to 180 degrees. When again? Now I must shift this graph where 45 degrees to the left again. Or this turning point to Sanji guy at this point again. And now this 90 degrees Sanji guy at this point again. Now at 90% katemu rayujo katagai at 45 when again. And then now Sanji 10 udima 180 10 udima guy 135 when again. And then from there, let's see the turning point here. And then now from there, it will move to 1 to 45 again. From there, or let's change color so that we can see the difference. Or you can simply use your calculator to get the points. But mine is giving me this point. Then from this point, it's going to cut this point from here. It will turn at this point and then it will move this direction, not that way. Because catch Orima 180. So it will be here. Then it's supposed to move somewhere like this. If I allow Orima 180. Then now from there, it will catch Orima again 135. From there, it will continue that way. But Sonji catch along the way of other part. Now, the red graph, that's what we are looking for. And then you must write your coordinates again. For now is what? Negative 45 degrees and 1 again. Then the turning point now is no longer at 180. It will be what? 135 degrees and negative 1. Then you can write the coordinates here and write other coordinates here. So more was very if you don't remember again, we just leave it. So at this level, we can just leave it. Even at this point, we can just leave it. Now that is the graph of x cos x plus 45 degrees. How many solutions does the equation of h of x equals to f of x have in the domain of minus 80 degrees and that one? So h of x and that one. How many solutions do you see? How many? There is this point here, one again, and there is this point here. So there are two solutions. So simply write what? Simply write two solutions. When I get, I think now you can see the light again. Now let's see here. They are saying show that the equation of 2 cos x. Let's zoom that. Right, show that the equation 2 cos x equals to sine into x plus 30 degrees is equivalent to square root of 3 sine x equals to 3 cos x. Now, what do you do here? This one is part of grade 12, forget. Because now, if you look at what is the amplitude of this graph, this side? 2. What is the amplitude of this graph, this side? So now, if the amplitudes are different, now it's more the co-ratio when I get. Because already, if you use the co-ratio, this cannot happen. We cannot have the square root of 3 there when I get, and this 3. So now, already, for grade 12, we have to expand this using a formula again. But for grade 11, it's not there. Or normally, grade 11, they will give you the same amplitude. Otherwise, we will fail to do the correlations. So, and if you see the amplitude being different, what do you do? We're going to use the tan method, and the angles must be the same. But now the angles are not the same, the amplitude are not the same, then it jumps to grade 12 level. Hence, otherwise, calculate the values of x. Now, we're not grade 11 or prove it can be that. Now, grade 11, now I move hence, or otherwise, calculate the value of x given that information. Our hence, or this answer again as it is. Now, I leave it to it. Now, which method are we going to use here to get the values of x? The angles are the same. So obviously it converges to tan. Because if you divide both sides by cos x, then we have tan again. This side will show like that again. So we can have this as square root of 3 tan of x equals to 3. When I get now this is tan of x equals to 3 over square root of 3. When I get now from there we get the general solution of this one. Again, now what is the general solution here? Let's get the reference angle. So kx is the second function of tan of 3 over root of 3. What do you get? Reference angle. Are you getting 60? Yeah? Come on, 60. So reference angle equals to 60 degrees. What? Namile, but for tan, they say we just find one side again. So in fact for tan we simply say now x equals to 60 degrees plus k dot 108 degrees, where k is an element of. So because we agree that the period of tan is 180 degrees, then you leave it there. When I get, if you use for tan, but for sine and cos you must go positive and negative. I get into the quadrant. Here is not necessary to do that. You can just get one side. Any questions? So that is simple as it is, and then they like to repeat this one. Yes. This one. Or expandant. Then also expand that. Let's expand. You're buying it. Let's say you're buying sine x, and then multiply by cos 30 degrees again, then plus again, okay, cos of what? X, sine of 30 degrees. So I'll give you special angles, sine cos of 30 degree. Cos of 30 guys. Then we have square root of 3 over 2 sine x. Then what is sine 30? Plus 1 over 2 cos of x. Then we'll take it to the other side. Yeah, cos. Then sine ya shala kama yabona. Agree lagana 2 lagana legi 2 cos of x. So what will like chance? Agree oral cos is to kama. Yeah? Then you work out your things. Then we multiply 2 wa shala square root of 3 sine x. So from the algebra, especially really expanding of this part, from this your algebra. When again? Right, and there on the graph they are saying this is graph of cos 2 cos x is drawn here from that interval to that interval. Write down the range. Let's minimize this. Simple questions. Here's the graph of 2 cos x is drawn for this interval. Now write down the range. What is the range of this graph? Yeah? Y is an element of, then you must do this again, minus and 2. That is the range again. Okay, question number 2. Draw the graph of g where g of x equals to sine. Now the graph of shifted in that case again. Now they say write down the period of g. What is the period of g? So let's just keep this. We'll answer it when it's required. What is the period of g of this graph? Okay. Simply because there is no the coefficient of this angle is 1 again. So simply 360 degrees. So 1 again. Let's check. For which values of x is g strictly increasing as x increases for negative 180 degrees to 180 degrees. Now these are the questions that we'll need to get. Can we draw the graph quickly? The graph of sine shifted by 30 degrees to the left again. So now the graph of sine, original graph will be something like this. It will be turning point here again. From here, turning point, and then from here to 180 again. And then from there to negative 1, and then turning point to there. When again? Can we shift this to the left by 30? Or is when you shift it again? By 30. This point must shift there by 30. This one must shift there by 30. And this other one, this one must also shift it there by 30 units again. Now let's draw the shifted graph and see what we can get. So right now, I'm going to have the graph passing here again. And then I'll shift at 30 units here over guy 60. I'll shift at 30 more over guy 150 again. I'll shift at 30 more over guy 120. Then there will be a turning point here, 1 again. And then now here we are going to draw category but somewhere 1 again. Now let's draw. Right, I know this is my turning point here. From here, this turning point, I'll move to this part, and then this will be the turning point here, and the graph will move that way. And then from there, you must go and cut to 180. From 180, my graph will be moving that way. And from this point, you must move that way. Now, the purple graph is what we are looking for. The red was the original one. Then you write, don't forget to write your coordinates again. Now this is the graph. Now, for which of values of x is the graph increasing? As x increases again, as x does what? Increases. So obviously x increases from negative 180 here to the other side again. So remember when you talk about the increased slope, we're like positive gradient again. Now let's running at turning point the gradient is tend to be what? 0 again because changing direction. Now we're going to check at this level. Let's check from this level because that's where there is turning point again. At turning point also more increase and decrease again. Now looking at on the left hand side, going that way. What is the graph doing? The graph of G, EG again. EDI, is it increasing or decreasing? Yeah? What is the slope here? What is the slope? Negative or positive? Because line here is what? And we're going to gradient again. Negative. For this side is increasing, decreasing again. Now from the right, going that way. What is happening to the graph? Now it's increasing. It's increasing. Now increase your face increase again. At another turning point. Turning point is here. So right at here, it must change from increasing to now this side will start to decrease. So now question in the values of x for which graph is what? Increasing. When on one line x is greater than minus 120 degrees and x is less than 60 degrees again because already the cutting values here 60 degrees and 120. So and then x already graph again increases between this one and this one. So clearly knowing x is between negative 120 degrees and what? And 60 degrees. So then these values are not included. Why? Because at turning point, because the graph is increasing or decreasing. That's where it will be 0. Then from 0 it changes the position. Any question about increasing, decreasing? Is it clear? So right, I also question increasing, decreasing to parallel. Because we can see clearly that we target the turning points again. From the turning point, then that's where we pick out the values. Because at turning point I have minus 120, and another turning point I have what? 60. So those values then you must come up with the right interval. Right now, let's see the next question. So this one is answered. For which values of x will f of x multiplied by g of x is greater than 0 for negative 90 to 90 degrees? Again, let's from what? Negative 90 to 90 degrees. So regular under this interval. And then what they say? They are saying when you multiply f of x again, multiply by g of x. So what is greater than 0? Must be positive. Now what is this one? This is y value of what? Of f. And the y value of g. Then when I multiply them, they must give me positive. Can you multiply them by positive? We can say positive, positive, or negative, negative. Now let's look at out of this interval. This is f here. This is g. Arshomega at 90. I can multiply. What is the y value at 90 of f? 0. What are we at 90? You can multiply 0. And 0 is 0 positive or negative. But now I'll 90k starting point saga because key 0 and 0 from 0 so a to positive or negative again. Namila area are graph still 90 on the left hand side. Namila remove that direction again. So I remove in that direction. Archega graph what is the value of y here of g? Is it positive or negative? Negative. Negative. So what is negative by positive? Asiginya ga yawan. Oraring kimo ga mo bale mo isale negative yawan. But the graph of G starting to be positive here. The value of Y starting to be positive and here is a positive yawan. My starting point is negative 30 degrees again. Because when I take the value here after 30, then I get positive. When I multiply them, they give me positive answer. So Shijiginale, agree for which values of x? Shijiginale one value again, x which is negative 30 degrees. So what? Can you see how to get the points? The values of x now. Kia tualeona, this are positive. Agree more from above the x-axis. Why am I positive again? So you change a guy. Only at 90, that's when I get 0. And 0 is to positive. So running, what is the next value? 90 degrees. What? Then now I have my 2x values. Now what is left is to write the interval again. So running, I'll not skip it. Then I'll say x is between this one and this one. X is greater than negative 30 degrees, or x is less than, not or, but supposed to be end, x is less than 90 degrees. So when I get, why get end? Because I want to move it because what I'm going to this area from here up to here. It's a when I get aska skip on the other side, but on this interval here, that's when I have my two graphs giving me positive. Then you've got your answer like this. Any question out of that? So this question, they are not difficult, but when is for you to understand during when you check out the y values, but check out with the x values, because the question is for which values of x. Right, here's another graph. Now write me the values here. Now it's you. Write me the values here. And I want to say, look at the graph of sine 2x and the graph of g, which is c multiplied by sine of dx from the interval 0 to 1h. The first one, they say determine the value of x, for which, or for x is an element of 0, where g of x minus f of x equals to 2. Value or values. Moloring y value ya g. Are minus y value ya f. Usonji refer by 2. What do you see? Come what? So because what is the y value here is what? For f. For g, y one again is 2 again. Then for f, come 0. So what is 2 minus 0? Then that is 2. So add what x value? Because they are looking for x value. So simply x equals to 90 degrees. One again. Now number 2, they are saying for which values of x where f of x is less than 0, less or equals to 0. What is less or equals to 0? We associate with decreasing. One again. This one we associate with, can you say decreasing? No. But for where values of y is equals to, or is negative again, this is negative or 0. Negative or 0. Now they want those values of x. But now reveal graph f. F. So reveal graph f for those values of x. And now we the correct interval where y is what? Negative. How do you go vane? Are vane logo na? Yeah? Or so this is the graph of f. Then we want y is negative, and negative requirement is also under the x-axis again, because this is y value, where y value is negative, and then I'm seeing this area here. Can you see that? And this area, so if you want to skip it, you use end. When I get so now it means your answer here will say x is between, and then you will include the equal, because why you include it again, between 90 degrees and 180 degrees again. Let's see if there is another question. Now they say g of x multiplied by f of x is positive. Now try out that one and give me the answer. Where you multiply the two y values of the different graphs, and then we get positive answer. Positive or equals to 0, and that's what we need to get. What else are you getting? What are you going to apply? Eh? Are you which? X greater than 0 degrees. Eh? Kung less than 90 ba? Kung wala eh. Kung fita mo x less than end. So what about this equal? Eh? What about this equal? You're not eating it. So it must be there because we're affiliate. I get. There are some cases where it should not be there, but it should be there. So around go penalizer if you don't write that. I get. You must make sure that if the equal sign is given, then you must write it. So, or simply you can write x is between 0 degrees and 90 degrees. I get. Any questions? These are the simple questions that you can get marks on. I get. Now they say f in the graph drawn above undergoes a transformation to result in g and h as given below. Determine the values of a, b, c, and d if g of x equals to c sine d x. Barring f in the graph drawn above, Izamaile undergoes a transformation to result in h. Again, to result in g and h. Below, determine the values of a, b, c, d, and if. Banyak ko ringana. Barring f uilen transformation abama abaji g go ga modi maget. Eh? G go ga modi maget. F level la f ma. Okay, what is the graph of this? Sine, cos, or tan? Eh? This is sine. What is the graph of this one? X sine x. What is the graph of this one? Here on side. Yeah? King. As a sine. That will also be sine again. But in the sine are one labels. Right, you 2 sine 2 sine. Yeah? 2 sine are one labels. Yeah, king. Sine what? Yeah? I don't want the function of this one. But feel you no go remove. Sine what? 2x. What was I going to so sine? Then Maria change here by again. You change here by 2 sine x again. Okay, but when you the transformation, what happened? What is the value? They say f of g of x is now c sine t. So what is the value of c? What is the value of c? It's 2 again. What is the value of d? 1. Because c kori ijiga how is it again? So ijiga guy at 2. Then c dl image the coefficient again. What is the coefficient now? Is 1. So that will be 1 again. Now they are saying h of x equals to a cos of x minus b. And h. The h is graph. Aye. Mararo sanjibe. What transformation do we have? H of x equals to what will be the value of a? Again, f above undergoes a transformation to result in what? G removed again, but h. So now h we are now a cos. When again? Now what should be the value of a? G again. Where is g? But f very now to 1 again. So what should be the value of a? That's supposed to be 1 again. Now what will happen to sine? Again, what will happen to sine 2x to be cos? What will happen to that? Now they want the value of b. What will be the value of b? Yeah? You're buying? Okay, quoi? You're back? 45. You must shift. Should it shift to the right by 45 degrees? Yeah? Remember, now let's sine 2x again. So, what should happen? 90. So, you shift again. Even 90 minus this one again. What is it? Cos again into 90 degrees minus 2x first. Again. Now, as no shifter, then now we can take out what? Common factor of cos into, again, what common factor can we take here? Minus 2 into x minus 45 degrees. Again, then now we know that this is the same as cos, again, the cos of negative angle will be positive. So that will be cos 2 into x minus 45 degrees. So that the value of D must be negative 45. Right? When I get the value of B. Yeah? Okay, again. I will inside the bracket. That's when we're solving x. We want the value of B. I will check out a bracket that over x equals to B. When I get. So that should be negative 45 because this is should be the value of B in that case. Right, here push it again. We've done that. Okay. Right, is there anything you feel a problem? Yeah? Page 50. Let's check page 50. 6.1. Determine the solution of 4 sine x. So that one, this one is an obvious case. We have to mark. How many terms do you see here? How many terms? On the left hand side, how many terms? On the right hand side, how many? How many terms? Yeah? So all with 3 terms, there's no way we cannot do without factorizing. So you must grab the technique again. Sky level choose. Know the technique again. Let's go and do it again. Let's copy it this side and then village 4 sine x plus 2 cos 2x equals to 2. When I get now, let's take this part on the other side. So 4 sine x plus 2 cos 2x minus 2 equals to 0. Now, because of this part is for grade 12 again, there will be a formula for that again. So 4 sine x plus 2. Now I want to substitute, I put brackets again. Now, because I have sine here, what should I change this cos to? To a sine again. I want to guide again. Because in this teacher cos sine, don't have problem. Unless munga begin cos multiplied by sine, then I can bring those two combinations. So you're buying it 1 minus 2 sine squared x again minus 2 equals to 0. We change as well. Alright. Now 4 sine x. Now let's multiply e plus 2 minus 4 sine squared x minus equals to I want to also move plus 1 again. So now she doing minus 4 sine squared x plus 4 sine x equals to. I mean, what do you see here? I want to common factor. Why? We're going to apply the minus again. Minus 4 sine x again into sine x and what? Minus 1 equals to 0. Also, you confuse, you can divide throughout by negative 4 pin again. Yeah, why again? Sine squared x minus sine x equals to 0. That's when you divided both by negative 4. I mean, what do you do from here? We're going to solve for sine x equals to 0 again, or sine x equals to minus 1. Oh, positive 1. Usana labsat. So raro factorize agmatata algebra again. So now from there you can conclude raro overall mini solutions. You must have 4 again. Because this part you only 2 year on. This part is only 2 year on. When I then you work out on that. Anything? Usana lengu? Eh? Right, let me give it the last one. We want to run into over a banana. Asangaradia, chan. Right, let's take this small one. Right, here's the parts. Just give me the solutions.